As we move into understanding weight and balance theory, Chapter 2 of the FAA's Weight and Balance Handbook has some interesting discussions we have to consider. This section we call the law of the lever. So in our earlier videos, we looked at the flying airplane and we looked at balancing the airplane in my intro video in week 8. The FAA uses this teeter-totter arrangement that we see here in figure 2, and this is the balance lever. In this scenario, a couple definitions we have to know about. One is the arm, and the arm is a distance. So if you see here's arm A, it's negative 50 inches. It can be a positive, it can be a negative. And then we have something called the datum, and just to review, the datum is the point from which we're measuring. If I've got a tape measure, right, I can measure from this side, I can measure up and down, I can measure from this side. It's all just a number in the end, and the datum is the end point of my tape measure, right? The datum is where I'm measuring from. Another term we need to know about is moment. Moment is actually a force, and it's the product of weight times arm. And so our weight and balance formula is weight times arm equals moment. But let's look at this illustration where the FAA did this. What they're showing here is they're showing a fulcrum that's a pivot point. So the fulcrum's my finger, right? And then you have a couple of weights. Now, all they've done is instead of showing this with an airplane, in fact, I can't balance it on that. I'm going to have to cheat, and I'm going to balance it on here. All they've done is to show us these balance points, okay? Now, what we're going to do is, as with an airplane, we're going to have weights in here. We're going to have people. We're going to have luggage. We're going to have all that kind of other stuff. So if I add another weight here, I'm going to have to slide this over. And this is all that they're showing us, is as we change the weights, we will change the balance point. And we're going to look, forget it, stop. Anyway, we're going to, as we change the balance points, we're going to change where these different weights lie. Now, these weights are going to represent things like passengers or baggage. So let's take a look here at their example here. We have weight A, and it weighs 100 pounds. And they're showing us this with this ball. And then we have weight B, and it weighs 200 pounds. So just like the old teeter-totter where dad's on one end and the kid is on the other end of the teeter-totter, it's a different length. The arm for this weight is 50 inches, and the arm to get it to balance, right? And then if we take the math, we're going to take this 100 pounds from this first the small ball here. And if our arm is negative 50 inches, and we're doing it negative and positive so we can keep track of which side of the balance point it's on. So we made the left side negative, we made the right side positive. It just makes it easier to figure out where we're talking about. So if we take 100 times negative 50, we get negative 5,000. Right? This is just weight times arm equal moment. And if you can see here, the moment is a product. It's this times this. And that's called a product. Right? But it's actually a force. It's expressed in pound inches. Arm is expressed in inches. Arm is a distance. Remember my datum. My datum is the end of the tape measure. And weight is expressed in pounds. So pounds times inches equals pound inches, or inch pounds, whatever you want to call it. So figure 2, they show us they've added more things to it, and so we've got two 100-pound weights, and we've got a 200-pound on here. Now they should balance. You know, if we got 200 on one side and 200 on the other side, it should balance, but they're at different locations. So mathematically, we're going to do the math. We're going to take the now look here. They made the datum. The datum is not the pivot point at this point. All your numbers are going to be positive, because instead of measuring it from the center of the pivot point, they said let's measure it from here. And because the datum is only the end of the tape measure, I can measure from the center, I can measure from this side. The length has not changed, but where I'm measuring it has, right? So we put the datum all the way to the left, and the first ball is at 50, and that's going to be 50 times 100. Weight times arm, right? Weight, 100 times arm, 50, is going to be like 500. Here's our chart. So weight 1 was 100 times 50. That's 5,000 is the product. That's the moment. Weight B is 100 times 90, 9,000. This is how we load an airplane. As we put passengers in different seats, they're sitting at different places on the airplane. So we're going to find the balance point. Weight number C, that's 200. 200 times 150 is 30,000. Now, just like when we weigh an airplane, we're going to add up the moment, and we add up all these moments, we get 44,000 is the total moment. We add up the weight, and if we add up the weight, 100 plus 100 plus 200, that's 400. And that will give us, then in our final thing, we're going to divide total moment divided by total weight. And that's going to give us 110 inches is our center of gravity. So if we go back here, sure enough, see the center of gravity, that's our pivot point, or it's a balance point. Our balance point is 110 inches from the datum.